Yeah, now taking the cue from Reddy. This is a 75 satellite missions. Engineer your satellite. I think we'll be seeing some sort of a overlap between the previous presentation, some PPTs and mine, but still wherever it comes, I will go through for completeness sake. When we talk about the 75 student satellite mission in somewhat a global scenario today, wherein the India the largest freedom uh, independent India. It's celebrating the 75 years. I think it has been this particular project is taken more of a national level, even to the global scenario. When the Prime Minister of India himself has put on record and which has widely published in the local media here. That means 75 satellite mission is the dream of the whole of 1.3 billion Indian dream, which connecting with both in and outside India people are calling. And as Mr. already Reddy has told, the mission has a scope of launching 75 student-built small satellite LEO. Obviously, the reasons being the first is towards the low Earth missions today. With the objective is to build on certain student skills in design, development, manufacturing, like that. So the methodology being told is providing a science-based education beyond even making the hands-on experience to make the satellite, wherein trying to bring in good number of ITCAs, bringing, as already study has told, a good amount of ecosystem, both the infrastructure as well as the brains are brought in together, such that they will be hand-holding the students to go for the next generation. That means through this unique mission, students will be able to compile a portfolio of signature space projects that will highlight their competencies to present, and they will equip themselves to move forward future. While doing this, just I think we cannot forget the history because India is celebrating 75th India's independence. India also has a modest beginning somewhere in 13, 14 years into its independence, starting its space program. A very, very modest way. Of course, taking hands from the erstwhile USSR, USSR and France for their initial baby steps. But slowly that started and trying to make their own satellite, launch elsewhere, and to make the satellite launch from Indian soil. Then gradually improving upon, you can see a marked thing from 2008 onwards. I think wherein the Chandrayaan made its presence around the moon, though it is 70th mission boat around the moon, it made a very good impact on discovery of water on the moon. And beyond that, it has a good number of foreign collaborations of 6 foreign instruments coming from outside. It made the visibility of Indian space program both within the national boundary and as well as beyond the national boundary. So that beyond that, 2008 onwards, the India's space program, the wing has started in a much better way. And there you can see good number of satellites being which are made outside being launched by Indian launch vehicle, and as well as some of the satellites, even the signature missions like WTM is a very big communication satellite made for the foreign partners. So, and now beyond that, even South Asia satellites that India made, and so that the other countries, neighboring countries of India, also making use of the space applications in a big way. And like that, many things happened there. And very many graduations that happened starting from 2008, wherein the mission Chandrayaan made a good visibility both within the India and outside India. So that means today Indian space sector, it has to be a snapshot. It is now beyond a government of India organization. It is now stretching its wings how even the academia and the private industries can come and play a meaningful role within the Indian space program. So accordingly, the space policy has been accordingly revised, and the launch vehicles, starting from the small satellite launch vehicle to the polar satellite launch vehicle and geosynchronous launch vehicle, and the various the orbits it can put, leaving alone the names, and from the small satellite all the way to the manned mission launching activities are come there. So when we are doing a good amount of other foreign collaborations also is in the place. But while this is happening within ISRO, ITCA also entered because Technology Congress Association is the Indian content point of view, various technologies. The cutting edge technologies, whatever has come, is trying to take either expertise to build up or the skill sets to happen within the India. So that way it's joining hands with the Indian space program in this changing scenario to taking, possibly converting the Indian space into a global space hub. And that to happen, towards that, what ISRO has done, and this is taken here. As I told here, 2008, a market difference happened, transition, big transition happened in the Indian space program. So accordingly, you can see from 2009 onwards, gradually the students started making the satellites, the hand holding of ISRO. And a good number of satellites from 2009 onwards, 10, 11, 12, like that happened there. And the latest one being UNITESAT, which is state of the art technologies, with ITCA's hand holding thing there, with a consortium of the institutions within India trying to make the satellite and launching. That is showing what ISRO has transited and ITC also joining, and academia also putting together. So this is the latest history of on which now we are trying to sit in the 75th year is concerned. Parallelly, ISRO also from 2018 and 19 is concerned, every year bringing in good number of non-space-faring nations as today, bringing them and giving them some sort of hands-on experience, like them a small satellite in-house. Like that today, because of the COVID, I think the last 2 years not much happened. But as of now, around 33 countries across the globe abroad, and given the hands-on experience of how they can engineer the small satellites is concerned. So you can see some sort of a convergent transition, the spiral way it's happening, both ISRO and as well as ITCA and academia. And it's not only within the Indian boundary and stretching its wings even beyond that also. So now connecting the Indian Technology Congress Association, ITCA, to this particular thing is concerned. Yes, it's using from all the way from agriculture to agronomy, all of many of the cutting edge technologies being harnessed, and Indian Technology Congress is doing a remarkably good presence in the Indian subcontinent to taking the engineering and technology here next pedestal. Now, when we're talking about in this scenario, as Mr. Reddy has already told, now when we're looking at how India has progressed and how Indian space program has progressed, and how the academia and ITCA joined together. So all these three pillars together. Now you look at here when 75th year of India's independence has come. Now, yes, India is celebrating, ISRO is celebrating. Now ITCA and academia, how we can go with the basis whatever I shown there. In terms of making the satellite, in terms of showcasing the academia capabilities and putting the things together. So the idea is to celebrate the and commemorate 70 years of independence by launching 75 missions, 75 student satellites. That means the whole concept of this 1 year celebration across the nation is to make aware the Indian youths what is the freedom struggle people have made to get this independence, and then generate ideas in 75th year and resolve them in 75. Then you have an action to go ahead in the future. That means, but still we should achieve something within the time bound of 75th year. So 75th year is one side to look back with the gratitude what our freedom struggle have done, and another side take action such that our future is better. For that, make the concrete programs and do it and show it in the year of 75th India's independence. As Mr. Reddy has already told, with this ethos, Indian Technology Congress is joining hands with the synergy with the various industry partners, both within India and outside, with both academia and is concerned. So finally, basically to arrive at the mission purpose is to encourage the students to embrace STEM education, in pursuit of long-term professions through experimental hands-on learning beyond the classrooms. It provides innovative, fascinating, and constructive space projects that foster problem solving and critical thinking. I think you know that the satellite technology provides a very good of opportunities because of team building, solving the problems, many things is happening there. So, but now while doing, we should keep in abreast with what is going on there. As rightly as told, Space 4.0 provides that triple eyes of how to interact, innovate, inform, and inspire the people. So that is the first way, and that's accordingly it moves forward. So now, while doing, the students' participation enables many things to happen. To strengthen India's renewed economic policy by creating employability, skill development, many things can happen there. So, 75 satellites to be built and launched. As I told, this year something to be achieved. So that is the thing. So that will enable a future startup fueled by entrepreneurs. So that may enable all these sort of things. So it has a multi-dimension thing. One side showcasing this can be done, and in the process of making this mission, the students will get a end-to-end life cycle experience of making the students. That means design, develop, test, fabricate, integrate, and launch the CubeSats within the short time period is really a, a, a very ambitious goal, but that used to be achieved. And while do that, as I told, these are all the contemporary space tech applications, starting from global brand connectivity, all the way TV, radio broadcasting, your lines. Many things are happening, many things are in a place, connecting the billions of beyond all these things, Industry 4.0 or something like that we talk about. It connects billions of devices and assets. That's man to man, man to machine, machine to machine. These also things are happening. But to enable that, definitely the satellites, especially lower satellites, are going to play a meaningful role. So that it's still keeping in mind that the sustainable goals of UN also meant to do today this project is already in fact 30 years ago. But while doing this, yes, the global trend is to go towards the satellites, the small satellites in that state. That means whatever we do now is basically is not totally very old, and it is keeping abreast with what will be there. That means when you talk about up to 2030, how the satellite numbers will grow. That means whatever we do now here is definitely a lot of thoughtfulness for at least minimum another 1 or 2 decades concerned, as we foresee today. That means the prominence of lower Earth is very well known, and that means whatever the platform what we are working is good. So, but when we're talking about that, again, it's classified into the small satellites into um, all the way from the 100 kg satellite to even sub 1 kg satellite is we talk about. So, but when we talk about in this scenario, 1U, 2U, 3U configurations we are talking about, and that way the student satellites when we talk about from schools to the universities point of view, and there is a good possibility of various ranges of things could be done. As far as but while doing it, what really it can be done? What really it can be done is this can lead into a good number of indicative payloads what are given here. I think that it can be tested in some form or other. It can be tested by the single satellite or the cluster of satellites is concerned. So that way it can help in various ways, like what Industry 4.0 is connectivity of very many systems, starting from healthcare, manufacturing, textile, even the drone application, aerospace, many things we are talking about that. But to enable that, definitely satellite and with the small satellite configurations will enable in a much better way. Now coming to the engineering in a queue, whatever we're talking about, these are all the targets what really we can do. We have to make a satellite. So that calls for in a phased manner of making the arriving at a mission objective, then define the mission things, then you have a preliminary design of the overall mission. Then you break down them to the subsystems. Even though textbooks are available, now we have to make it a new system for our own purpose. So subsystem design is called for both, and that you have a good number of softwares available to can be validate the designs, and then you go for the first making the satellite, maybe a verification model, then go for engineering model, then test it, and in the process, you understand the pitfalls, issues, something like that. Then go for the flight model. In between, you qualify your models, whatever you have done. Then they test it and test in the space-like environment and the launch. So that means this holistic life cycle of multiple phases will enable the students to know what is there into making the satellite, what is there to design it, what is there to arrive at the concept, what is there to design it in various models with the qualification model, engineering model, and finally going to flight model. Then a big change of launch, and beyond all these things, post launch. Okay, so this the holistic thing will be able to a good number of things there. And while doing that, it has a good number of subsystems like communication system, electrical power system, attitude determination control system. Then when we do everything, there's the first of the system. Then data management for the payload in which each one of them come out. We will talk about sometime later. There is a possibility of the universities and the institutions can come out with their own novel application using that platform. That's called the payload connector. While do all these things, definitely we should ensure the reliability is a primary and integral factor in the design. Because once you have done it here, just launched, so there is no way to take it back and correct it. So it just work in a very, very reliable way. Considering that the space weather is very, very, I think, in terms of geomagnetic storms or radiations, many things. So such things can, yes, it's indicated here, it can damage the electrical components, cripple the satellite, many things can happen. But then similarly, the space test, these are all the environment. Against this environment, it has to work. So that means a reliable system is to be arrived at. So while doing it, we got to create a balance between what is the overall mission requirement and capabilities of the satellites. And while doing, definitely money also involved. So you have the choice between commercially off-the-shelf available systems and the space hardened components. Space hardened components, it will sustain these things, but money-wise, you have to spend more money. But if you are able to design it properly, in spite of this, it will not affect the components like that. Your system design takes care, and you can have the commercially available off-the-shelf systems we can make. So that way, there is, as an engineer, you will able to do in optimization and trade-off and things we can do that. So while doing it, we should ensure that it's not hit by space debris, and you also should not create a space debris. So these are also very much required. And once put in orbit, as a post-launch also, which orbit satellite is working, when it's coming to visibility, sort of things that we seen there. So like that, and even after that, some internal problems happen working in 400 kilometers away. And whatever the signal comes here, we must be able to decipher what is the issue, if anything, is there, whether the system is working or not. So that way, even from the concept to the operating, getting the signal down there, a lot and lot more the students will be able to learn in a big way. This system is concerned. So that means how we will do it. That means the way we are going to is we must, when we talk about this particular mission of when we're talking about only or two satellites, less than a kg type of thing we're talking about there. So that means it will be low cost and with the available time is less for us, because when we are being universities cannot spend a huge amount of money. And now we already told within this year it should be launched, less time available. So that is, but luckily we have advanced miniaturization and digitization available. So putting the things together, I think we can do it. But while doing it, it does education and skills and technology, demo, scientific temperament, and future jobs it will generate. But who will do? Definitely, this target is schools, colleges, universities, and that will be supported by the industries which are already handheld by the ISRO, or Israel, or the Japan, or Serbia is concerned. So these government space agencies also to some extent can help. But numerous countries in the world also, when we're talking about UNISEC, I think a number of other experts that also happening there beyond Indian countries. So then definitely it is within this year. Before 2022 end, I think we should do it, because it is 75th year of India's independence. So while doing is all these things, India's domestic capabilities, as I already told, what ISRO has done it and its capabilities, and it has brought out some very good number of Indian industries also, the capabilities available. And ITCA and TCS put together the latest three satellites designs available, with the lessons learned also available. Accordingly, the computation has come. So, putting together the launch opportunity for ISRO's entities, because Prime Minister of India himself has declared it. I think we hope ISRO's the positive support is happening there. That definitely will happen. So So this will happen, launch will happen within India. How is basically, this is because why, what, who, when, where, how. This is what the building in which the whole of science is there. And for the 75 visions, we are trying to answer all these things. The how answer is coming from Indian Technology Conversation, along with a good number of partners who you are all today as a part of this particular webinar. And while mission life cycle is concerned, we'll bring in ecosystem, already told, to scale up from concept to consolidation. Because as I told here, there's no satellite, we are talking about the one use satellite. Not only one satellite, it's 75 satellites. 75 satellites, if everything goes well, it will work as a constellation mode. That is really, really a remarkable thing will happen there. So that's how it will happen there. Towards that, ITCA will help how to get the world-class execution team on board to drive this mission, particular point of view. That's how the brain again they will bring in there, and as well as the monitoring and tracking of the whole activity ATCA will do, and helping for the design and helping for the manufacturing and helping the testing and validation, because that all the ISRO facilities, fairly well facilities, and as well as the facilities built by the private sectors also made available by ITCA. Finally, the launching, because it's very, very cost intensive. 75 satellite launching, getting the launcher is also easily tough, but I think we will enable to do that. So while just running through that, and this is the basic configuration we're talking about here. Some variants may be there depending upon the university configuration. It can be 2U, 3U possible, but a satellite configuration per se, I think what we are targeting ITCA and TCS concept something like this. Only satellite, and the solar panels is put all the places such that whichever the place comes, definitely solar minimum power is available there, and accordingly the communication point of view also it's available. So it is the basic system that will have its own communication system, power system, altitude control system, and onboard system, and which enable the payload which you can be make, and can be interfaced with the power, thermal, and the interface point of view. So available payload volume also has been given in this mass power point of view. Subsequent view graph will elaborate that slightly better. Payload volume, mass power. I think the projects will be made available. So it can be built and we can sit on this. This discusses about the mechanical arrangement and how much the power will be taken up from the bus system such that the payload is working. So how it interfaces, interfacing point of view also, this has been given such that some universities or students make the thing compatible for any one of this interface system. And accordingly, as I told here, it's reliable and other things for the space environment. Towards that, temperature rating and there, and indicative payloads also given here, and that will enable the further either for the constellation when they work together can possible, and very many things are possible. And these are just indicative things, but its imagination is the real topic. While doing all this, having done all these things, as I told, it needs to be tested in the space environment. It can help. So that starts with physical properties, launch environment scenarios, and towards that, when the launch vibration happens, that has to be tested in the ground in various ways, and various thermal cycles will happen there in the vacuum environment. These are all the specific special facilities will made available, and the students will have ample opportunity to know how it's happening. This is what are some of the tests going on. The previous that is concerned. TCS team is doing that. And that it's an acceptable level of everything that goes for launch. While doing all these things, I think every institution will be equipped with the ground station configuration, and that's also part and parcel of this particular project. That means when we make 75 satellites and the 75 institutes are there, means minimum 75 ground stations will be there. So this is a ground station set up to be established in the first campus, and that will be able to bring not only their own satellite, all the 75 satellites data in a time sequence mode. I think they're going to receive, and they will be able to within themselves they will be able to have a networking of the system is possible. So this is another host. When we talk about any space mission, not only make the satellite and how to get the satellite data down and decipher it, and again understand what is it there, and do good number of activities you can do. So that way it's a holistic thing all the way from conceptualization to the post-launch operating the satellite is concerned. So then when everything is happening there, definitely beyond even ITCA and TCS and the universities, ISRO itself is going to handhold or monitor how the progress of the project is going on. So that way, a good project management council has been constituted, and every expertise team will do what's going on, and all the way from top to end, and even enabling the test facilities within ISRO also made available to us. So that way, it's a one shot, even it's a premium, any of the institution to visit just the facility of ISRO. But now there is an opportunity for them to work with ISRO scientists in the facilities and having a very good feel about how things are going around. So it's really a bundle. It's not only a satellite they are going to launch, not only making a satellite and the testing and having an interaction with the ISRO expertise is going to be a thing. That means that it's not only that ISRO also will see to that this mission things are going in a proper direction. So while doing it here, there is the schedule when we're talking about here, preliminary design review already completed. Initially, it told it's all to be done. But now, what is happening? Where we understand when we talk about here, many things have happened. Preliminary design review of the bus has been happened there, and similarly, many of the systems, the lab level tests are going on. Then the components, when the good number of satellites you have to make, you have to procure the components. So that also activities already in place. And so when we talk today, I think you can on the dot you can see that where we stand. Okay, and this is the timetable it's being done. That means before the end of the year 2022, we must be able to put all the 75 satellites into the orbit, and that may start from somewhere in the August time. That means somewhere in July, minimum number of satellites. Some satellites will be ready for launch, but it will go in batches so that we will not put everything in one basket. So as I told here, even though 75 student satellites are made, the ownership is there. Any institution which is a part and parcel of consortium can have its own access to all the remaining 74 satellites also. So even if something happens, definitely good number of satellites data they will have to see. So nothing to worry about that. So again, all the 75 satellites will not be launched at one go. So that is also happening in the batches. So that way, switching from all the way from the month of July to December, we will be having the launch of satellites. That to happen, already many good number of activities are happening there. And today is what we are talking about when we talk about the May. This is the time period when the procurement of many components are already in the place. And then that means June, July onwards, when the systems will be keep assembled there. The students will slowly get a feeling about that. Then they will keep participating in the environment tests, as I told here, thermovacuum test, there's vibration test, and thermal cycle test, EMI, EMC test. Many tests are there. So they will part and parcel of that. Then slowly from August 15th onwards, when ISRO is ready for the launch, in the PSLVs or SSLV, whichever the launch vehicle available to match our orbit requirement, I think that there the launches will take place. So that means we can look at here already we have crossed more than 3/4 of the time period. That means we are sitting at the 14 identified item. We are sitting at the item number 10 today. Okay, procurement is happening by June. That's over. So almost in that timetable sitting there. So you can have the feel about that's very ambitious. So while doing it here, what's it mission deliverable? Okay, this is what the institutions will get. Okay, depending upon whether 1U or 2U or 3U, and there are some financial implications. But depending upon that, whatever the MOU you have signed along with ITCA, you will get there. Along with that, primary, secondary payloads, you can have it. So this is a host of things will be delivered. Either you will be knowing, you will be having the hardware in your place, ground station on your own there, and you will be part and parcel of the many of the activities, whatever is happening there. You'll get a good number of training towards that, learning resources, training materials, many things, both audio visuals of the small satellites will be made available. So very many things will be part and parcel of that. Beyond that, you will be part and parcel of the work ongoing with respect to manufacturing and the testing and the launch campaign. What will happen in the launch pad? So it's a really a package we are going to get beyond even the satellite, and you will have your own satellite in a lab model. We also available even beyond being launched. That means. A good amount of activities will happen even beyond that. So it's a really good thing to happen. So the value position is it's a really a disruptive innovation for new space solutions. And because the smaller doesn't mean it is a small, it's going to make a big impact. Because like your cell phones, previously phones were big, but now smaller cell phones making a lot of impact. Smartphones have come like that. This satellites what we're talking about 1U, 2U are the small satellites will be the smartest satellites can possible. But while doing it, definitely multidisciplinary training is possible there. And beyond students, even faculty also can enhance their competencies in progress research activities. That is a very many, very key. So now today, ITC or ISRO is hand holding. This is only initial baby step. Like whatever I told ISRO. ISRO also started its work with the SOL, USSR and USA and France spacefaring nations were hand holding in 60s. Today, ISRO is hand holding the US students, but now subsequently that faculty can enhance their competencies and they can do a good number of research activities. So universities, institution gain substantially through collaborative incubations because it's not only within the institution and you will have minimum 75 institutions. And there is a very good possibility outside this also, India also, that good number of institutions can join with us. Probably that that announcement ITCA may do soon do. So that way will help, and good number of industries also part of that. So your collaborative research and it's very much feasible in this concept. So that way, the student satellite when we are making, the stakeholders are very ready, and what they gain is going to be a really leap and bound within this 1 year time period is concerned. And while doing it here, it is not absurd, it is structured content for the young minds. Okay, and the structured and the graded course materials will be made available on space and related aspects developed for school students. Latest technologies. I think that is a very more thing. It's not the history we are going to talk about. What we're talking about is what is happening right away and what is expected in the years to come. I think that's what that. So that means access to course material through learning management systems will happen with the 5 big ideas of perception, comprehension, learning, and natural interaction, and it will make a very good impact. So new basis for the curious and creative minds. I think that is the buzzword that's happening there. The potential opportunities and beyond all this may look like philosophical, but now beyond all these things, concretely look at here, what sort of job opportunities possible? The students, when they come out of this, beyond the graduation, they can you a host of job opportunities, starting from system engineers, space lawyers, GNS engineer, product research engineer, project manager, machine vision engineers. You look at many things, oceanography, plasma physics, so much of works. I think the possibility exists. Data scientists a big work, data analysis a big work, and therein you will now get a good amount of hands-on experience in this particular field when you are entering here. That means with a host of job opportunities available beyond being an entrepreneur. I think is another thing is the entrepreneurship is also very much visible. That means future endeavor is concerned, use this self-sustaining ecosystem that increases options and opportunities, as I told here, that can be leveraged by stakeholders to save the future of space. It is future of space means the individual, the organization, the nation, and the globe. I think you will be part and parcel of that to happen. The opportunity for India to build a collaboration with more than 90 spacefaring nations are very much visible. This will scale educational infrastructure, create high-skilled jobs, and boost the Indian economy. So that means it's a holistic thing, though this baby step of small satellites of 70 satellites. That means 70 student satellite mission is a mature platform for collaboration because, as I told, there are many steps we have taken, starting from 2009 and ANUSAT 40 kg satellite, when the latest UNITY-SATs were launched, a lot of graduation happened there. So this, when we are making this effort today, it's a matured platform for collaboration and cooperation in the space research, creating a pathway for inflow of expertise. That means with this, ITCA is nurturing the 70% mission to deliver value for institution, faculty, and students in the realm of real new phase. I think that is the main thing. Just I run through the few of the view graphs, just showing the photos of what's going on. I told already going on. So this is typically for the Karnataka state, how they are, the students, they want to get it connected. This is with the school students. I think already a lot of activities happening there. When coming before reaching to this level, ITCA and TMS at stage, have the student satellite program. I think the last 3 years going on. These are all the basic things happened before reaching here. And Indo-Israel Space Tech Leadership Program happened. That means when we are happening here, lot of base work has happened there. It is satellite development and Serbia. I think starting from CANSAT, very many activities happened there. And so these are all the people, part and parcel of this, who learned from here, who taught from there, all are part and parcel of this. So ITC and UNISEC collaboration also part and parcel of this activity, and a number of conferences happen. Today's whatever webinar is one such thing, bringing the minds together. And team partnership is, as I told, it's across the globe, very many people are there. And within India also, from ISRO, all the other industries also, part and parcel of startups or industries also giving. That means you can see the access possible and the expertise available, and the facilities we have an access is really a big number we talked about. This talks about the student satellite mission in India, that is UnitySat, whatever has been launched in 2021. And after the post-launch, the team is celebrating that. And this is the post-launch celebration, wherein the local minister also part and parcel of thing in this success meet. So why I'm doing it here? A similar thing we expect a year from now for the 175 satellites that we are launched, and we are looking at there. I think there is every possibility. Whatever the path we have gone through that, I think similar pictures, we definitely will also be able to do that. Towards that, I think we have a good number of strategic collaboration MOUs, memorandum of understanding, with various institutions across India. This is the latest collaboration, universities, institutions, progress mission. Some of the recent partners alone I have put it here. I think it's keep growing, and something is maybe missing also, because otherwise every head will be very tiny thing. And this is the core of the team, in which they will be project management as well as technical team, through which I think you will be the students satellite program, the institutions will be interfacing, and they have their own expertise when making the these starting from CANSAT, making the UnitySat, and they are their students. I think they are startup also they have done. That means they are the models in which the students will look upon, and so that they will have visibility. Yes, this our elder brothers are part and parcel of this making, and they have done it, and we are doing. So that is another life example, life model, when the people find this work is concerned. While doing it here, definitely elderly wisdom also is the backbone of this particular mission. So with this, I think thank you very much for one and all part of this today's session, and I think I expect a good activities in the months to come, and this UNISEC meeting also we enable.